Welcome to the DIY Honda Garage channel. This presentation covers the DTC B1000, which stands for Communication Circuit Error, commonly referred to as bus off, specifically for the Honda Civic models produced between 2006 and 2011. This error is significant because it implies a malfunction within the communication bus system, which is essential for the functioning of multiple electronic components in the vehicle. The bus system is a network that allows various control modules to communicate and share information. When an error like B1000 occurs, it could impact crucial vehicle functions, possibly leading to performance issues or component failures. This guide goes through the components affected by this error, potential causes, and detailed troubleshooting steps necessary to identify and rectify the issue. The DTC B1000 indicates a failure in the communication circuit, impacting various control units within the Honda Civic. The primary components affected include the gauge control module, hands-free link control unit, and the immobilizer keyless control unit. Each of these modules plays a vital role in the vehicle's operation, from displaying engine diagnostics on the dashboard to facilitating hands-free phone communication and securing vehicle access. These components are interconnected via a communication bus located within the vehicle's wiring harness, which allows them to relay information to each other. A malfunction within this network can prevent normal interactions, leading to observable deficiencies in vehicle performance. Understanding the roles and locations of these components is essential for effective troubleshooting. The possible causes for DTC B1000 are multifaceted. Firstly, loose or poor connections can disrupt the electrical signals traveling through the communication bus, leading to communication errors between control units. Secondly, wires that are worn or shorted may also create faulty connections, causing intermittent or complete failures in communication. Additionally, a faulty control unit could be the root of the issue if it cannot send or receive signals correctly. Each of these causes requires thorough inspection and testing to confirm whether they contribute to the B1000 error. Addressing these potential issues is imperative to restoring proper communication between the vehicle's control modules and eliminating the DTC. Symptoms of DTC B1000 can include various warning lights appearing on the dashboard, indicating that there is an issue with the vehicle's electronic systems. Additionally, some control units may become unresponsive, which could lead to failure of features such as the vehicle's gauge readings or hands-free communication functionalities. In some cases, the vehicle may exhibit a total lack of electronic features that should otherwise work correctly, which can lead to a frustrating experience for the driver. Observing any combination of these symptoms may help pinpoint that the B1000 DTC is active and thus necessitates thorough investigation. Proper diagnosis can save time and prevent unnecessary repairs. The first step in troubleshooting DTC B1000 involves clearing the diagnostic trouble codes using the HDS, or Honda Diagnostic System. After clearing the codes, turn the ignition switch first to the lock position and then immediately to the on position, also referred to as the III position. It's important to wait for at least 6 seconds after turning the ignition on to allow the control modules time to initialize and communicate properly. This step is crucial as it resets the DTCs and helps determine whether the error is persistent or an intermittent issue. When complete, the technician can check for the presence of DTCs again with the HDS to continue the diagnostic process. After performing the initial steps, the next action is to check for DTCs again with the HDS. It is essential to confirm if DTC B1000 is still indicated after following the reset procedure. If it is indicated, proceed to further diagnosis. Conversely, if DTC B1000 is not present, this could imply an intermittent failure of the communication bus line, suggesting that the wiring or connections are likely functional at this time. In such cases, technicians should inspect for potential loose or corroded connections. Additionally, the technician should verify the battery condition and assess the charging system, as these can also affect electronic communications. Next, the technician will again check for DTCs using HDS, this time looking specifically for related DTCs such as B1008, B1011, and B1032. If any of these codes are present, it indicates a broader communication issue involving multiple control units. This scenario directs the technician to the next diagnostic steps to identify the problematic control units. Conversely, if none of these DTCs are present, it suggests that the issue may reside within the microprocessor integrated control unit, commonly referred to as MICU. Following this assessment, the technician should replace the under-dash fuse or relay box, indicative of a fault within the unit. For the fourth step, turn the ignition switch to the lock position again. After ensuring safety, disconnect the appropriate connectors at each relevant control unit, such as the gauge control module or the hands-free link control unit. This step is critical as it isolates each unit to determine whether the B1000 DTC clears when any one unit is disconnected. After each disconnection, the technician should clear the DTCs and recheck for the presence of B1000. If B1000 is still indicated, it suggests there is a persistent issue and further investigation is warranted. Otherwise, if the error no longer appears, it may indicate that the control unit previously disconnected was faulty. In this step, disconnect all appropriate connectors for each of the control units specified earlier, including the gauge control module and hands-free link control unit. After disconnecting, review the power and ground connections at the control unit that previously did not reset the DTC. This review is critical because malfunctioning power or ground can cause communication issues similar to those indicated by the DTC. If both the power and ground are determined to be functional, it necessitates replacing the specific control unit, as it is likely malfunctioning. This step highlights the importance of systematically isolating components in diagnosing communication errors. After completing the repair actions, the final verification step is necessary. This includes ensuring that all connections are resecured and properly seated. Once visual inspection is complete, the technician should test the system functionality to ensure all electronic features are operating correctly. This includes checking dashboard gauges, the hands-free communication system, and any other electronic amenities. Furthermore, the technician must recheck for the presence of DTCs using HDS following the repair. Successful absence of DTC B1000 confirms that the system is functioning as intended without communication failures, ensuring reliability and proper vehicle operation. Preventive maintenance is essential in avoiding future occurrences of DTC B1000. Regular inspections of wiring within the vehicle should be conducted, particularly for areas near the connectors or where wires may experience wear. This includes checking for corrosion in connectors, which can disrupt communication. Proactively maintaining electrical systems can help to minimize issues arising from poor connections or damaged wires. Additionally, it's important to regularly test the vehicle's battery and charging systems, as a weak battery can exacerbate electrical communication issues. Implementing these strategies can greatly enhance the reliability of the vehicle's electronic systems and prevent similar diagnostic trouble codes from reappearing. In conclusion, DTC B1000 represents a significant communication circuit error within Honda Civics manufactured between 2006 and 2011. Following the outlined troubleshooting steps methodically leads to diagnosing the underlying issues accurately. Key aspects to consider include addressing power and ground connections, as these can heavily impact the communication within the vehicle. It's crucial to ensure that all control units in the communication bus are functioning correctly to avoid further malfunctions. Regular preventive maintenance can play a pivotal role in preventing the emergence of DTCs, thereby extending the life of the vehicle's electronic systems. Ultimately, a systematic approach and diligent care can drive successful repairs and enhanced vehicle reliability. Please like and subscribe to the channel. See you next time.